As we continue our discussion on statistics, in this section we're going to look at what are called measures of central tendency. It's basically picking a number that somehow describes perhaps a big collection of numbers. So, given some data, a list of numbers, how could we best describe the data with one single, kind of a centralized number? There are three commonly ways to do this. One is the mean, one is the median, not medium, and the last is the mode. And in this section we're going to talk about all three of these, the mean, median, and mode. We'll start with this, the mean. Well, the mean of a list of numbers is the average of the numbers. You can think of mean and average as meaning the same thing. So the population mean, which means you look at every single number in the particular population you're talking about. Let's say it's in numbers, and here's how we could represent them. The in numbers, we could represent them as x sub 1, x sub 2, all the way up to x sub n. And we compute it as follows. It would be mu, that's the Greek letter mu, which is frequently used to mean the mean or average of a bunch of numbers. You could write it as a fraction like this. On top you put x1 plus x2 plus dot, dot, dot. You go all the way to the last one. Add up all of the n numbers, and then the number of numbers is n. You divide it by n. Another way of writing that would be, in parentheses, I'll put x1 plus x2 plus dot, dot, dot plus xn, all in parentheses, and then out front put 1 over n times that sum. This is equivalent. These two are equivalent. So once again, you add up all the numbers and then you divide by the number of numbers that you added. Now, what do you do if the population is really large? If the population is large, then n is a very, very large number. It could be in the millions or the billions. In this case, it may not be convenient or maybe even possible in a short amount of time to compute the mean or the average. In this case, we might use what's called a sample mean. And it's going to be used basically as an estimate for this mean. It's going to be the average of some sub-collection of the population. So, for example, if you wanted to get the average height of all the girls in a elementary school or a school that goes from kindergarten through 6th grade, and you don't have time to go through perhaps hundreds of them and measure their heights, you might just want to pick one or two from each grade. Sometimes the toughest part is coming up with the sample. It needs to be kind of a random sample. If you picked all of the girls from 6th grade, that would probably mean that your average is going to be way too high if you're looking for an average of the entire school. If you picked all the kindergartners, the heights would be lower. So you'd want to kind of spread them out evenly over the population. So if we were to choose m numbers, m is smaller than n. It's just some random few sample numbers from this entire set of numbers. From the population, where m is, here I said, considerably smaller than n, then to get the sample mean, which we refer to as x with a bar over it, x bar, we would simply add up the m numbers and, what would we do after we divide them up? Divide by, this time it's m, because there are only m numbers that we added up. Okay, so it's very, very much related to the population mean. The population means just says you're able to get all of the numbers in question, every single one of the numbers. If there's too many numbers here, you might take a sample mean, which means just take a few or a smaller number from this set and average them together. All right, well, we're going to look, if we're not stating specifically, we're going to be getting the population mean. And in this case, the mean, this is the entire population. There's only 4 numbers, so I'm not going to choose 2 of them and get a sample mean. Let's just find the entire mean, the mean of all 4 of these numbers. And we would simply write it as the mean, mu, is 91 plus 88 plus 62 plus 75 all over 4, because there are 4 numbers that we're adding together. So I didn't have my calculator ready. Hold on, let me get my calculator. I will do 91 plus 88 plus 62 plus 75 equals, and then divided by 4. And that gives me a 79. Okay, so if you received these 4 test grades in finite math, your average score would be a 79. Number 4, let's do it again. But notice this is going to be slightly different only because notice that some of these numbers repeat, which is perfectly fine. But we're going to find the mean of these annual salaries. And if you don't know what a K means, that looks like $25, but when you put a K in front of it, it means $25,000, $14,000, $18,000, and so on. So let's say that these were annual salaries, and we're going to compute the mean, or the average salary. It'll obviously be something in between the smallest and the largest numbers, so it looks like it'll be somewhere between 18 and 25. But here's what I mean by grouping the data. The mean is going to be, let's see, 25K. It only shows up one time. 25K plus, actually I'll leave the K's off, and until the end I'll put a K on. Let's just look at the numbers. Okay, now the 14 though, how many times does 14 show up? 1, 2, 3, 4. So instead of writing out 14 4 times, I'm just going to write 4 times 14. Plus, now let's go to 18. How many times does it show up? 18 once, twice. 2 times 18. What do we have left? Just 20. Plus 20. I could put 1 times 20, and I could have put 1 times 25 over here, but it wouldn't change anything. Now, make sure you don't simply look at this fraction and say, I'm adding up 1, 2, 3, 4 numbers. We're not. We're adding up 25, and we're adding up 4 copies of 14, 2 copies of 18, and then 1 copy of 20. In other words, 1 plus 4 is 5, 6, 7, 8 numbers. And if we go back up here, 1, 2, 3, 4, 5, 6, 7, 8 numbers. So make sure that 8 is the denominator. So let me see, let me simplify this a little bit. Maybe I can do it without my calculator. That would be 25 plus 4 times 14 would be 56, I believe. 2 times 18 is 36 plus 20 all over 8. And let me go way over here in case I need more room. Okay, let's see. I'm going to do the middle two first. 36 and 56 would be 80, 92, 102, 112, and then plus 25 would be 137. So 137 over 8, written as an improper fraction. And let's see, how many times does 8 go into 137? Let's see, 8 times 15 would give me 120. So it looks like it's going to be 17 and 1/8. So we could write 17 and 1/8. Maybe I'll write it like a, you could either write 17 and 1/8 K for my final answer with a $sign, or 17.125 written as a decimal K with a $sign. So I'll write the answer like that. It could be either one of these. So as we suspected, it's between 14 and 25. If you add them all up and divide by 8, you'd get an average salary of $17,125. Because remember what a K means. It's that many thousands. If you multiply by 1,000, this decimal point would move over 3 places. $17,125.